Tired of hearing me say this over and over and over again, but it is so important that you understand this. So when we dilate a figure on a coordinate plane, we multiply the x and y values of each ordered pair by the given scale factor. Now, if my scale factor is greater than 1, so that means greater. If my scale factor is greater than 1, it creates an enlargement. If my scale factor is less than 1, it creates a reduction. And I know I've said that about 8 times in the last like 2 days, but that is something that you have to remember, that if your scale factor is greater than 1, you get an enlargement. If your scale factor is less than 1, you get a reduction. And then we can find my scale factor by doing new over original, or the image over pre-image. So if they give me my scale factor, so in this case, they gave us the scale factor. I went ahead and wrote the points in here for you, so we're not sitting there looking for points for forever. So I'm basically going to take each one of my ordered pairs and multiply it by the scale factor. So in a sense, I'm doing this, I'm doing this -6 times 1/3. So if you multiply 6 times 1/3, or -6 times 1/3, you get a -2. If you multiply 3 times 1/3, you get 1. So I basically took each one of my values, my x value, and I multiplied it by 1/3, and then I took my y value and multiplied it by 1/3. And I'm going to do that for each one of my things. So this gives me a prime here. So 6 times 1/3 is going to be 2. 3 times 1/3 is 3. That gives me b prime. And then if, again, 6 times 1/3 is 2. -3 times, oh, I messed up right here. That should be a 1. 6 times 1/3 is 2, and then -3 times 1/3 is a -1. -6 times 1/3 is a -2, and -3 times 1/3 is a -1. Basically, I took each one of my x values and multiplied it by 1/3, and each one of my y values and multiplied it by 1/3. We can go and graph this then and I know this graph is a little bit messed up right here along this scale, so just count each one of those lines as 1. So I'm going to go to the left 2 and up 1. That's going to be a prime. I have 2, 1, that's b prime. 2, -1, and that is c prime. And then -2, -1, and that is d prime. And since my scale factor, ooh, I put that in the wrong spot. Since my scale factor is less than 1, it makes sense that my shape got smaller. So I have my larger shape here, and it reduced because of my scale factor being 1/3. So here's where the rule comes in. Basically, I have my x and my y that I start out with. And when I dilate it, I am multiplying my scale factor times each one of my ordered pairs. So I'm basically doing 1/3 times x, and I'm doing 1/3 times y. And that is your rule. Plain and simple. So nothing too big of a deal whenever we go to write our rule algebraically. So if we're looking about compare the image and the pre-image, and it says what attributes did the dilation preserve, we're not going to really worry about these things down here. We're not really going to address that. So on here, you don't have to go and fill in the pre-image and the image on every single one of these. If you know that it was a scale factor of 2, you know that you're going to have to take each one of your coordinates and you're going to have to multiply each one by 2. So if I have x, y is my original order pair, I know I'm going to have to do 2 times x and 2 times y to get my new order pairs. And this should be something that you should be paying attention to. If my scale factor is 2, is my new shape going to be an enlargement or a reduction? You should know that that 2 creates an enlargement. And so your shape would be bigger. I know this is not drawn proportionally, but your shape would be larger than what you're given. Again, you don't have to write down all the ordered pairs. You literally, if it is giving you the scale factor, all you have to do is write the rule. So if I have x, y, I know I'm going to do 3 over 2 times x, and I'm going to do 3 over 2 times y, and that is my rule. Again, if you simplified that down, it would give you a scale factor of 1.5, which is an enlargement. Again, if you were looking at this, your original shape would be bigger. Again, not drawn to scale, just to give you a visual. Now, on here, sometimes they have you find the scale factor. So to do that, there's a couple of different things you can do. You can go and count the side length. So if I count this side length here, I know that it is 1, 2, 3, 4, 5. So I'm going to do new over original. This is my new shape. This one's my original down here. So I counted 1, 2, 3, 4, 5. My new was 5. I'm going to pick the corresponding side of my original shape, and I'm going to count 1, 2, 3, 4. So my scale factor is 5/4, and so my rule would just be easily 5/4 y or x. Sorry. And then 5/4 y. On here, and it made sense because I went from a smaller shape to a bigger shape, so it makes sense that my scale factor was 5/4. On this one, I know that I'm going, this is my new one and this is my original one. My scale factor should be less than 1 just by looking at it. So I'm going to count the side of my new, and this is the corresponding original. So I'm going to count the side 1, 2, 3. Let me rewrite this so that it makes sense. So new over original. So I have 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. And that simplifies down to 1/3. So my scale factor is 1/3. And if I wanted to write my rule, it would be 1/3 x, 1/3 y. On these, you're literally just putting new over original. This is your new one. This is your original one. So if I pick my y value, I'm going to put it over my y value. So if I have 8 over 12, I simplify by 4. That gives me 2/3. So my scale factor is 2/3. So on these next ones, you don't really have to go and write the new order pairs. I want you really just writing the algebraic representation. If you would like to write the order pairs, you're more than welcome to. And then I want you practicing finding the scale factor on a couple of these and writing the algebraic representation. Don't forget to take your formative. If you have any questions, there's Zoom today, or on today, which is Tuesday when you watch this, at 2:20. It will also have a Zoom Wednesday at 2:20. And then I will have a Zoom Thursday. It will be at 2:40 because Thursday's a late arrival day for us here at school. Okay, so if you have any questions, make sure you jump on and ask questions. Have a good day.